Once upon a time, there were three cowbirds who took a walk to let the hot chocolate cool. Goldilocks broke into the house because he was a hungry brook student at Cal. He sipped the hot chocolate and burned his tongue.
We want to calculate and contrast the heat transfer coefficients of a system in which air cools hot chocolate with and without convection. We chose a ceramic mug to carry the hot chocolate and insulated the sides with a scarf so that we can assume perfect insulation. Heat escapes only from the top and water evaporation is negligible.
First, we measured the heat transfer coefficient between hot chocolate and the static air at room temperature, a system without any convection. And we add 1 tablespoon of hot chocolate and 0.35 liters of hot water at 80 degrees Celsius to ignore heat vaporization to the mug. We measured the temperature every 30 seconds for 9 minutes and we repeat this procedure 5 times.
Now a CBE 140 student used forced convection to cool the hot chocolate faster. We repeat the same experiment as before using a fan. As expected, the temperature goes down faster because the heat transfer coefficient is greater. We repeated this procedure 5 times.
Using this equation, we can calculate the heat transfer coefficient. We assume that the heat capacity of hot chocolate is equal to the heat capacity of water, as we only use 1 teaspoon of hot chocolate. And with the solution of this equation, we can plot a graph, and then from there we can calculate the heat transfer coefficient from the slope of the linear value.
For the system without convection, the heat transfer coefficient is
5.86,
and for convection, the heat transfer coefficient is
12.12.
as convection allows for faster heat transfer. Some sources of errors include potential unwanted heat loss. As an alternate idea, the CBE student could have used the bowl for a larger surface area and faster heat transfer, but people don't drink hot chocolate from bowls. If we weren't limited in time and resources, we could insulate the mug more completely and get a more precise thermometer.
Thank you for watching!